Hey, thank you. Recording is in progress. Thank you all for showing up in large numbers. Thank you also for those who registered that I know and all the other people that I don't know, but it's going to be, I hope to entertain you with a bit of knowledge that I can share on Python. So this is the first interactive session. I will take you through a couple of, I'll basically summarize the stuff that I taught before. If you want to ask questions, do so in the chat or raise your hand and see what Dutra and I will see what we can do with your questions. So the idea is to create some interaction, you can stop me and ask questions if you want to, like in normal seminars. Good. So again, welcome all. What I'm going to do first is, show you take you to a couple of these seminars that are or sessions that I already organized or did and posted on my Netlify website. So this is session 5. It's available on Netlify as well, but it mainly refers to the previous 4 sessions. So yeah, so why Python? A lot of people ask me why Python. Well, first of all, I think, it's one of the fastest growing languages, computer languages in the world, and or if not the largest or the fastest growing language. So it is useful to learn a language that is well supported and which has a critical mass. That's the first thing. But that was not really the reason why I chose Python myself. So, maybe I can sort of use a couple of examples of my own experiences with Python before I bore you with all sorts of statistics on why you should use it. The main reason that I started using Python was more or less that I needed it. I needed a programming language to deal with large data sets. And so, large data sets are, are clunky and hard to manage, especially the data sets that were large a couple of years ago, say 7 or 8 years ago. Computer processing power was kind of limited, and software like Excel struggled with it, as well as Stata. So I needed something more beefy, and so the choices then were either convert to SAS, which I dreaded always for reasons unknown, but I never liked SAS very well because it took me too long to get stuff going with SAS. And then I thought, I can either use R or Python. My experiences with R were a bit mixed. I once in a while tried it, and it never stuck. I always got stuck in something that I couldn't solve myself easily. And so, once you have a project and you get stuck a couple of times, then you give up. So the other alternative was to use Python, and it turns out that the language is such that I never really got stuck. So there's always support. There's a large critical mass of users that uses Python, and so whenever you ask a question on type of question in Google, explaining your problem, then there's always a website like Stack Overflow that can help you. Yeah, the other thing that I found very good in comparison to, say, Stata, was that Stata code is not very easy to read, and code maintenance in Stata is not easy. It's kind of unpractical, and the language is clearly dated. And at the time that I used Stata, I started using Stata in the beginning of 2000. But for a long time, you could only have one data set in your memory, and so and I found it a very bad thing. You have all these redundant columns and variables, and so that is kind of unhandy. So I thought, let's try either Stata or R, or Python or R, and I stuck with Python. The code is readable. The program itself, or the programming language, is versatile. You can use it for anything, like for programming games. You can do research with it, but you can also do research in different disciplines like biology or whatever other fields. There's always something there in Python that can help you out. So I'm not only using this for research. I wrote an app that allows me to send SMS messages from my computer in Python, which is kind of funny, but it's often quicker than opening up your phone and so forth, especially if the battery is dead. So therefore, the language is so versatile that you can use it almost on a daily basis for various, for solving various problems. And also, for people that are limited in resources, the language is largely free. The only costs are your opportunity costs of time. Yeah. So the main reasons for me were to switch was in particular code maintenance and readability and versatility. And think of this: if you start a project for a couple of years, then in our field of research, you have to work through a project for a couple of years, before start and end. The time lapse between start and end of your journey through an article will take you a couple of years. In those years, you probably have had 3 updates of Stata, which is fine, but also expensive. And also, a code language like R changes quite often, changes over time. And I found Python remarkably stable over time. Yeah, so just a couple of examples here that'll take you through. So code readability, you may have seen some of these Jupyter notebooks that I presented. That makes conveying knowledge very simple in Python. There's no equivalent like that. Other languages have, that rely on Jupyter notebooks. There are like Julia and maybe R, but the traditional languages like Stata and SAS don't have such a nice and readable interface, or for a long time didn't have such nice and readable interfaces where you can mix language as well as code and pictures in a website like Jupyter does. So things you can do, there's many libraries here. Pandas and NumPy are my favorite. And so whenever you do research, and over the 5 upcoming sessions, I will predominantly focus on pandas and the use of pandas, because that is my weapon of choice. It absorbs data, large data sets, but also it allows you to organize the data very neatly and clean your data. And what we call data munging can be done, almost only with pandas in the way that it helps your research moving forward. Then there's machine learning languages or libraries like Scikit and TensorFlow. You can use that. I tried it a couple of times, and it's just very easy to, once you know a bit of Python, adopting these libraries is easy and straightforward. Sometimes I need to do research with my co-authors like David Lont and Paul Griffin. We work on climate change, and it turns out that GeoPandas is very handy for all sorts of geospatial analyses. Then for those who have access to WRDS or Icon, what is it, Refinitiv Icon now, there's add-ins for Python that allow you to access the data straight from WRDS into your Python environment without the need for saving the data to a drive, which then saves a lot of drive space and organizing of files on your hard drive. Yeah. Same for Icon. There's an API that allows you to access Icon data using Python, and that that's kind of allows you to organize your data in such a way that you don't have these, reams of files with all sorts of different timestamps, and you get lost in that. It's much easier to import your data straight into your Python environment without the need for saving. And then there's various, APIs that allow you to download various other sources like Fred data or ECB data. The ECB has a wealth of data, and that that data can also be accessed very quickly from into Python. So other advantages, I think collaboration is easy to do, with GitHub, and then there's various packages that allow you to collaboratively work with Python as well. So there's Collaboratory, Datalore, and NextJournal. You can try with that. These are free Python interpreters that allow you to share data. Also quite handy for Python is that it imports most of these file formats with great ease, and it also allows you to export data to these formats. I'm not sure if you can export to SAS, but all the other formats are well supported. Either import or export, as I showed a couple of days ago. Then there is web scrapers. I use a web scraper myself for various things, and that can be easily done through a library called Beautiful Soup that allows you to download all sorts of web-based data straight into your Python environment. I hope I can show you a couple of examples on that as we go through this lecture or this session. The output in Python, sometimes tabular output is easy to do. You can save pandas tables to all sorts of formats, Excel, print, and Markdown, as well as LaTeX. Graphs also are very nice, and you can, the tweakability or the ability to tweak your data, your graphs is almost unlimited. Like the graph shown here is fully constructed by Python, and all these things like circles and dots and lines and annotations and arrows, that can be all programmed into the graphs. You know, that makes it kind of easy to replicate and update your graphs without, you know, a lot of work. Yeah. So that's one of the reasons that you can use Python as well for the graphs. They're kind of good. There's graphs that are more orientated towards those that use statistics. There's a package in particular called Seaborn, allows you to make these graphs here where you have, you know, correlations and distributions neatly presented in a, was it 4x4 graph? Or correlation matrices can also be produced very quickly with Seaborn. Yeah. So for data analysis, you can use various packages like stats models and linear models. But now with Stata 17 out, you can easily integrate Stata into your, you know, if you really need some of these fancy econometric techniques that are only available in Stata, you know, you can just use Stata now these days and then port your data from a pandas data frame into Stata at the background, run your analysis using the Stata econometric techniques, and then get the output from the econometrics from Stata back into your Python module. So the great thing about this is that all the advantages of data cleaning, data management, and tweaking and munging data can be done in Python, but for some hardcore analysis, like, you know, advanced panel data analysis, you may as well revert temporarily to Stata, which can run in the background. I do that myself, you know, for the most advanced econometric techniques. I just rely on Stata integration here. It all goes seamless, and it adds some additional oomph to your Python experience. Yeah, here. So yeah, there's a couple of examples. I show these ones too, and you might as well take a look at these two programs. I thought, you know, it's pretty sure that these guys won the web scraper of house pricing in the UK. If you go to that research from the French ACP, I think, from the French Prudential Supervisor, you know, if you go to that paper, it's just impressive the stuff you can do with Python. And then there is one also paper on the ECB, I think, which looks at Twitter use and whether Twitter helps to convey messages of the European Central Bank. That also relies on Python. And so these are the applications for research which can be done easily with Python. Okay, so going back to my, let me see, to session 5. So that's why. Session 1. Oh yeah, some example of my own research before, you know, I can show you a couple of stuff, couple of papers that I did here. So here's a paper that looks at the value relevance of various capital adjustments that banks make, regulatory adjustments to capital that banks have to make under Basel III and also Basel II rules. Now, I'm not going to bore you to death with the paper here. I presented it a couple of times, it's now in the review. But all the research here has been done in Python, you know, data analysis, everything's done. But what I like most is the graphs here. So what we demonstrate is the relationship. If you use elasticities to measure the relationship between changes in, say, book value and market values, what you can see, that's the blue line. Over time, these elasticities are very close to 0. So 1% in book value leads invariantly to 1% in the coefficient, in market values. That is, you have to adjust for the market to book ratio. But if you ignore the market to book ratio, you see a very stable relationship between the relationship between book values and market values. That's the blue line here at the close to the value of 1. Now, I'm not going to explain a lot about this paper. You can read it yourself. But this graph is fully written in Python, so including the bands, the ticks, the legenda, the arrows here, the colors, everything's been set by Python, including the two y-axes, one with a unitary scale and the other with the scale in thousands. So this is a type of graphs you can produce with Python. And here's a couple of other graphs. I like this one in particular. So you can plot the numerical values of outcomes. You can plot them here on the dots here. So all these values are nicely plotted, and you can use Python for that as well, and combine that with a more traditional graph. And there's more of that. So this is one example of a paper where all the numerical and quantitative analysis has been done with Python. Yeah. The other paper that is on headroom, which is a popular topic now in the banking world, is does headroom, which is more, which is the amount of capital that you have over requirement, whether that matters or not. There's a lot of work for this paper. All the analysis here have been done by Python as well. Again, here what you can do, so a graph like this can be easily made using Python, this one is on the capital stack. Now I hope the colors shine through well. It looks a bit like spacious colors, but they're all kind of shades of green in the PDF paper. Everything here in this graph is being done by Python, including the positioning of these labels, which coincide with the levels of these the labels as well. So that's one Python graph. Here, an overlay of European bank capitalization. I may have to increase the font a bit for publication, but what you can do is superimpose, country data on top of the graph, and then use colors for the intensity of, say, capital. So what you can see is the weakest capitalized countries, according to the, to my research, are the countries further down to the south of Europe, and you see that the countries further up north have high capitalization. Holland is well capitalized, mainly because I take the average, and there's one bank in particular, a very small bank that has 40% of equity or something like that. So it's well capitalized, driving up the average number here, making Holland look very well capitalized. Fair enough. What the graph shows is that you can impose, you can have these countries with colors and numbers, everything on top, and also superimpose that on a normal Google map, with the normal familiar green shades that we are used from using maps. Yeah, here's some more traditional graphs that you can create. And so, yeah, it's all doable. And making these graphs is kind of relatively easy. This is a correlation matrix, but then visualized, so you can see the various correlation. Again, here there's a module for crafting these correlation matrices. And so this gives you an idea about, the correlation without having to read all these numbers. All the tables are made with, at the background, everything is done through Python as well. And then I imported in LaTeX. So that's the stuff that I do myself. So yes, I spend some time on a daily basis doing research using Python. It has become my tool of choice. Again, here for those who want to start, my message is very simple. I have 3 children, and 1 or 2 of them they come to me once in a while and say, I want to learn Python. And I say, why would you like to learn that? And yeah, okay. And so after a while, they just don't do anything. And that's fine with me, because the only reason why you should learn a programming language is if there is a need. So in my case, I'm just reinforcing the idea of, the best thing if you want to learn something is to make yourself wanting to use it. So either a strong commitment to learn it, but you have to adopt some sort of project, or start a project, a simple project, and see if you can do something. And then as you become more skilled, then it starts coming. But if you're not really intending to switch over to Python and stick to traditional methods, then it becomes much harder. So you have to feel the need in order to commit. And once you commit, it more or less goes automatically. It's like any normal language, there's no need for me to learn Latin, because why would I learn Latin? But if I were to be ported over time, or enter a society where people do speak Latin, obviously there's for me a need to start learning that. And so you have to impose that need on yourself to make sure that it works. And once there's so much help available online that it's hardly an impediment. The lack of support can't be an impediment here for Python, because there's sufficient support in many ways. Okay, so the second session was more or less about the moving back to stuff that you need to know to install before you can start working with Python. First and foremost is make sure that you install Anaconda, because that offers you the entire research suite for Python as well. And then secondary, it's the number 2 requirement, not a binding constraint, but still important, is to install GitHub and get a bit of basic knowledge of GitHub. I'm not a specialist in GitHub myself. I just use it to post stuff and to download stuff. But just make sure that you get going there. It's very simple. It takes you about 10 minutes or so to get sorted with GitHub. The best thing in the world in terms of support is Stack Overflow. That's this website here. There's a wealth of questions on various Python topics. I myself am here. I once in a while ask a stupid question, and then even people, there's some people that even take it seriously and come with answers. But so Stack Overflow is really worthwhile, a big helper for those who are starting with Python. And the great thing about that is, if you post a question, then the best answer gets voted up. So I'm not sure what this question is. Find the end of the month and Python data frame series, so that's a question. And then, this answer here is the best answer and it's being voted up by 129 times. And so you don't have to trawl through pages of forums, like traditional forums where the answers are at the end. Here the best answers are at the top, which makes life a lot easier. Yeah, so that's very good to have. Yeah. So Anaconda allows you to install using this line here. Whatever package you Anaconda install, you can use that to install any package. But sometimes a package is not available on Anaconda itself, and then you have to use pip install, and then the package name. So there's 2 ways of installing additional libraries. Get familiar with that. There's so much help there that allows you to learn this very quickly. But if you miss a package, you can use it like using either Anaconda or Conda install or a pip install. Right. So a couple of things. We're going to spend a couple of notes on Python commands. So therefore, I'll move to to my GitHub page, which is also visible through various links on the ARC primer page. A couple of things you need to appreciate. A lot of the stuff if you do some basic programming in Stata or other languages, people know strings, integers, floats or real numbers, booleans like true and false. Some people know date variables, but the real power in Python is the lists and the dictionaries. That's really, really worthwhile looking into. And the power is such that the way you deal with lists can sometimes lessen the need for things like for next loops, which are I find always very ugly. So lists and dictionaries are the most powerful tools in Python, and in particular, there's something that is called list comprehension. Months. Okay, just briefly on list comprehension. Here. So normal people that have done some programming, I'll just enlarge it a bit. If you do programming, you maybe have seen a for next loop like this one here, for blah, 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 and then for some sort of variables loop through these numbers, in this case, from 0 to 12, and you loop through a list, but it's kind of inefficient. There is a slightly better version of that is for x in months. If you have 12 months and the list of months, you can loop through each of these months like this. So this is months is a list of months. Where is it? Something here. Oh yeah, this is months. You can convert the months to a list, and then you can loop through them, which is shown in this using this formula here. But the greatest thing about, as I said, about Python is this use here, where you don't have to enter a separate loop, but you write it like this, like X for, or Y for Y in months. And then it loops through your months automatically. And you can do all sorts of stuff here between the square brackets. So in this case, I'm going to add Q dash before each month's name, like January, February, etc. So I can do that using a for next loop, like the one above. But if you do it like with list comprehension, it becomes a single line, which doesn't generate a separate X in your variables environment, which keeps your variable environment kind of clean. So get used to that. It took me ages to understand this comprehension, but I'm almost addicted to it. You know, there's so many things you can do with that. And in particular, if we move on to pandas, you can use list comprehension to select the columns of the variables that you want. Like I want all columns that start with text. And you can do that using list comprehension like this one here. Yeah, so get used to list comprehension. That's kind of good. And the same more or less applies to dictionaries. There's also dictionary comprehension. But once you get the principle of, once you get the hang of this list comprehension and dictionary comprehension, you're pretty much, you know, totally converting to Python. Yeah, so that's the most important thing. On the, yeah, I'll try to enlarge. There's one question from Tim. My resolution is patchy. Okay, I'll try to enlarge it as large as I can. Why not? So most important thing is that, you know, CSV files, you know, everything can be imported using CSV, or, you know, it's very easy to import CSV files. One thing you can do is compress them, and then and that saves space. But the great thing about you know, having it compressed is that you don't have to tell Pandas or Python to uncompress it, because that will be picked up automatically once you load the data. So so even a bulky CSV file, if you compress and save it, it saves a lot of space. The other thing, and that is what we will go into the future, is to use the Pandas data frames. And one of the most important things there for Pandas is to start learning the indices, like you know, apply an index to a year. Yeah, I'll come to that, you know, in the next session. The great thing about these plotting requirements, you know, the plotting is very simple and straightforward in Pandas and Python. So you can download from the website. You can download this file called gle.csv. And the file looks more or less like that. Yeah, for mu and mu dp, you get this information here. Now, what you see here is a column at the far left with 0 to 4. You're never going to use these numbers 0, 1, 2, 3, 4. You will never do that. What you want actually to use is these years. And then once you have the years, you can focus on the substance of your frame, which is the numerical information with all the decimals here. So what you can do, and it's one of the most powerful functions, and there's where I think Python excels over R, is that you can index. You can use indices, but these indices are often recognized, for example, in plotting. So what I'm going to do here, you know, this data frame here looks like that. I'm going to set year as index. So first, I'm going to try to plot this data frame, and what you get is useless information. You get the blue line representing the years, and then you have some sort of blurred yellow and green line presenting the information that we're interested in. So how to circumvent that problem, how to get rid of that problem, is to apply the index year to the data frame. So you say the data frame is now a data frame with an index, and the index is year. Yeah. And then you get this data frame as a result. And here's where, you know, Python Pandas helps you propel your research very quickly. You know, we currently see a single index, but in many cases we have firm year identifiers, and you can have two indices like year firm, and then you can group by year firm, or you can group by year or firm, etc., etc. So a dual index or a triple index is quite often a very neat way of organizing your data. The other thing is you can sort of manipulate the mu and mu dp columns by, for example, adding 1 to it, or dividing them by 3, or multiplying them by 4, without affecting the years in your data frame. So you can just say, I want all these values multiplied by 3 in this data frame, and all these values here will be multiplied by 3 except for the years, which is actually what you want. Yeah, so that's far easier to manipulate data. You can sort of shove all the stuff that you don't want to manipulate, you shove that into the index, and then the remainder will be exposed to your changes that you apply. Yeah, okay, so once you have an indexed data frame, you can do the plot thing here. So I'm going to plot is a method that applies to data frame, plot that, and then you get much more, a much better graph where it's a nice legenda, nice colors, and automatically you see the years being processed as years, which are readable years. And so Panda recognizes the years and puts them in the x-axis. Yeah. That's kind of cool stuff. And here's an example of multiplying everything by 2. I multiply the data frame by 2, but in this case, given that I put the years in the index will not be affected by my multiplication. So you don't have to worry about anything that's in the index. It's not going to change. The only thing you can focus on now is multiplying or dealing with the numbers that are not indexed. Yeah, and that is one of the most powerful things that makes Python stand out of many other programming languages, the ability to index. And you can use multiple indexes in the columns, but you can also index the column names. Like you can have double, like in many cases, you can have two rows instead of columns of column names. Yeah, so we're used to having one variable for one column, but sometimes you can group variables using multiple indices for the columns, which is also a possibility on pandas. Yeah. So that's kind of cool stuff. Okay, I'll leave it at that because it's 33 minutes after, so I overstayed my presentation. So my suggestion would, I think, to hand it over to Dutra to ask questions.
Okay, thank you very much, Martin. Now we're going to the next. The idea is just to leave everybody to ask questions. I have several questions from all the audience, but I'm open to everybody. If you want to ask questions, just open your mic and ask directly to Dr. Martin. And if there's nobody that wants to ask live questions, I can read all the questions that I already have from the audience.
All righty. Any volunteers?
So I will start with one question, Martin. The first one is, what does it take to become fluent in programming for people from a non-STEM background?
Okay, yeah, one of the participants asked that question, how to become fluent. I think the main important thing is, as I said, just start and start with a project and then commit. And then don't back off because you're temporarily depressed, or just keep going. But the most important thing is, like with marathons, just tell everybody that you're going to start, and then you will run that marathon. If you don't start, or don't people you start, it's probably commitment is probably low. So commit and start doing it. There's so much support that you almost never can get stuck.
Okay, now we have a question from Ahmed.
Yeah,
please open your mic.
Hi, can you hear me?
Yes.
All right, thank you so much for this session. This is the first time I actually attend, so obviously I have a lot to catch up on. I'm kind of familiar with Python, but I'm not familiar with GitHub at all. So how would you recommend I go into GitHub? What's the basic things I should know about it? How do I get started? Stuff like that.
Oh, the only reason for now, I think for now, is to clone stuff to your hard drive.
Okay.
So if you do, how to clone a GitHub repository, that's all you need to know.
Okay.
What happens is basically the entire, all the files that you see in the repository on GitHub will be downloaded on your hard drive, and so you have access to it.
Okay.
So that's and then for now, that's most important. If you want to upload stuff, you need a bit of more time to figure that out. But for now, it's basically only, what they call clone, and then subsequently you pull stuff. So you just pull all, and then as a result, you pull stuff from the repository into your own hard drive. And once it's on your hard drive, you can access it and play with it.
All right, thank you.
Good question.
Okay, thank you, Ahmed. Now we still have some questions. Robert, please.
Hey, Martin, thanks for that. It was a lot of stuff that you tried to cover, and good to see you. I'm a Perl coder, but obviously one reason I've resisted Python is because it feels like Perl in a straitjacket. But more sensibly, I think the thing that Python gives us is a lot more libraries that help us to do a lot more things. Pandas, for example, and that certainly beats Perl out of the water. I guess my question is, in order to get started, the way I learned Perl was I sat in a cafe and I read the Camel book. Is there an equivalent for Python that will get me into thinking in a Python way when I want to get started?
Oh, okay. Yeah, two things. I started with a simple book called Python for Kids. And you can still download it, but it's kind of it's kind of dated. So I read that in, say, an afternoon, and then I felt ready to do my own stuff, like the simple stuff, like for next loops and while, and that can be done with Python for Kids. The next one you have to order or read is the Pandas book by Wes McKinney. So here's there. I just look up his name, Pandas, and the great thing about Pandas is that Wes, who wrote the book, he worked for AQR, which is I think a major hedge fund or a private equity firm in the US. And so, my guess is that he wanted to have a Python equivalent for Excel. And so a lot of the Excel functions are just available in Python, plus a lot of stuff that has to do with financial calculations, like interest rate calculations and everything that has to do with time and time series and calendar time and dates and because that's all very important for the financial industries to be able to calculate interest rates from day to day, from hour to hour, or price movements on a high frequency. So it's all there. It's much more suitable for financial research than, say, R, which has a more generic approach to science, and Pandas in particular is extremely useful for those working in financial industry.
I didn't catch the name of that second book, so perhaps you could type it into the chat. I'd appreciate it. Thanks so much. Cheers.
Yeah, so what is it? I can just Google it. The book is a bit old now, I think. Right here, it's called Python for Data Analysis.
Okay, great. Thank you. Cheers.
And that's it. So I can show. Here we are. That's the one. Read that from cover to cover, and you'll be fine. Yeah. Other question.
Okay, thank you, Robert. Now we still have some live questions. Ting
Hi.
Dong,
Yes.
please.
Hi, thank you. Thanks a lot for this presentation. It's really helpful. So I have a question. I was using Python a little bit before, and I found it difficult to visualize the data sets if I have large data sets with lots of columns. So what is the best way that I can easily see all the data?
Okay, yeah, well, I was playing today with some data that I wanted to visualize, which was large data. I think if you work for larger data, but I'll come to that in a later session, the tool of choice would be to use Seaborn. That gives some additional flexibility. Yeah, I don't know, if you cannot visualize a lot of columns, that's impossible because then your picture becomes very crowded. So you have to make a selection of columns, which then is easier if you use a Seaborn.
Okay.
Seeing if I can show some of the visualizations. Yeah, well, oh yeah, well, I had one on Google mobility data, but okay, I'll leave that at that, for later. Okay, maybe move on to the
thanks.
question.
Yes, there's a question from Diego, please.
Diego.
Hello. Good morning. Congratulations on your presentation. Yeah, I have some question and comments at the same time. I'm a user of Python, R, and Stata, and as far as my feeling, and I don't know if you agree with me, the main benefit of Python compared to other packages like R or even Stata is basically on web scraping and textual analysis, because there are power library. But on top of that, for a researcher in accounting, I don't see great benefits in using, for example, Python compared to R, because R, for example, includes both the econometric part. So you need to use Stata for more advanced econometric part, but also there are some, is a very powerful programming languages. So what do you think about that?
Oh yeah, no, fine. You have to learn at least one or two languages, and I wholeheartedly support you with the choices you make. My experience thus far with R is, I tried, I once tried R because it's a New Zealand-based language, and I thought, let's try that. And then at some point I got stuck, and it takes too long to to get unstuck. And the other thing that I found not so great with R, it has a lot of advantages. But when it comes to the manipulation of data, there were at the time that I learned too many formats for data. Like, so, now you have for Python, there's only one that's more or less only pandas, but you have 2 or 3 equivalents for R. And so it's confusing if you want to find a solution, because, half of the messages are about one package and the other for a different package. So it's more the package mess from R that put me off from continuing with R. And I just got too often stuck with it. So then I thought, might as well do something where I get less stuck. So yeah, either way.
Thank you very much.
Yo.
Martin, we still have one live question from Mark. Please, Mark.
Mark.
Thank you. Thanks. Just a quick one, Martin. I just wonder, I'm still learning Python from a very low level, and I'm working with people in the university who use it on a high power computing system, and therefore are using Python more through the terminal window, using basic editors directly, and or even Visual Studio Code, something like that. Now, so learning Jupyter then it seems to be an additional layer on top, and I wonder if you have any sort of advice on whether it's easier just to persevere with using Python through more direct access rather than via notebooks.
Well, to be honest, for my own work, I hardly use the notebooks, because you can't see your data environment. So I may switch over to my, to my Spider environment. Let me see. Right. Oh yeah, here. So let me switch. So what you can see here is my Python environment. This is web scraping. So what it does is it requests data from the Dutch health authority. It downloads data on COVID cases. Now this is obviously a bit of a macabre graph, but it shows you how to to use data straight into, or to port data straight from the Dutch health authorities into your Python environment. And so I use Spider for the stuff that other researchers may use Python using a terminal, which I dread. But Spider is kind of handy because on the left panel here in yellow you see the code, and
yeah,
and then here at the top in the right hand panel you see the variables that are there. Now there's only one data frame, which is a very large data frame, and then there's some data. So this is my variables, and then there's a few. I can click here to this tab. You can see the plots. And then if I execute a command, I can do that again. I can run the command again, and then you see the output being generated here, like 1 and 1 is 2. So you have the best of all worlds. You have your code on the left, you have your output on the right, your environment as well, and your your own command window, which is more or less the terminal here at the right bottom.
Yeah.
So Spider is a similar package as Visual Studio Code, but it always confuses me because there's always updates and there's always changes, and it's not as intuitive. The only drawback from Spider is that maybe the user interface is a bit dated. Fair enough.
Thanks. That's so helpful. It's a bit like RStudio, isn't it? It's a similar sort of.
Yeah, it's very much like RStudio.
Yeah, thanks.
The difference is here, I think you can execute here just pressing F9 and you get the code executed, which I don't think RStudio has, but it's similar to that.
Yeah,
Yes.
thanks. That's really helpful. Thank you.
Cheers. You're welcome.
Thank you, Martin. We still have some questions that were posted during the registration process. Very good question. One from Julia. Can you provide some introduction on working with pandas?
Yeah, I will do so because that's going to be, if you commit to this course, then pandas will be the your weapon of choice for a long time. And so I will come up with some examples of pandas. I can, going back to this frame here, just what is pandas? It's a data frame. I will explain that in, as we go forward. The great thing about pandas is that it allows me to convert data in a couple of lines, which you can see here is in a handful of lines. It's about 30 lines of code. Much of that has to do with the making of the graph. But, in the 30 lines of code, it imports data from, the other side of the planet into my computer. It digests the data and then process it in straightforward. And the main data repository here is the data frame called DF, which stands for data frame. And so I can do head DF head. And it gives me the top of the data frame. And so it's extremely powerful. What you can see also here is that there is a date column, which is, a pandas date column. And then there's some other columns as well. I may try to open this one. Oh yeah, it is open. And so this is this is how you can sort of explore the data frame with all these cities in Holland where people are suffering from COVID. Fair enough. So that's how, and the processing of these data frames, that is going to be the mainstay of this course, because that allows you to, to munch your data and to get it in a shape that you can present it into a plot like this one here. All right.
Okay, thank you very much, Julia, for your question. Now we have a question from Leo: how to use Python to clean data?
Yeah, well, you will spend a lot of time cleaning your data, especially with large data. There's sometimes very strange stuff going on in the data. So sometimes, the typesetting of the numbers and the data is just very weird, and Python offers almost all solutions to clean out messy data. So this is one of the most powerful tools I think I use. Not all data comes from WRDS in a nice format. Sometimes it's messy. Sometimes it comes from a PDF, and there's many tools that allow you to clean it up. So yeah, we'll spend a lot of time on cleaning data and sorting and mashing and resampling and grouping, splitting. Yeah, that's going to be the future.
Okay, thank you, Leo. Now we have another good question for Hoang. Is Spider better than Jupyter Notebook?
It depends, the Jupyter is great for explanations, like the one that I showed here on my, this is a Jupyter website. So, this is excellent for explaining stuff. But as you can see, there's nothing here really, it shows nothing in terms of the variables that I'm using, the environment. Plots are not always easy to demonstrate. So for my day-to-day work, I use Spider. For teaching Python, I use Jupyter. But that's up to you. There's other ways there's many other ways of programming Python.
Okay, thank you, Hoang. Now we have a question from Berking. I mainly struggle for basic issues. That is how to work with CVS file, how to open folders, getting the results by name of each file, etc. Can you comment? Go ahead.
So on that, the last session number 4 already does some of that. But I noticed that, I grew up in a time that PCs had folders and directories, and you learn to deal with that. But it's not God-given that everybody understands folders and directory structures on your PC. And so I think I posted in one of the lectures, I posted a link to, how does it work, folder structure, and how to deal with that. So it's not part of the language, but or not part of the course, but I'm aware of that deficiency on some of you, that you may not be familiar with that. Yeah, and then the other stuff, I will take you through that over the next coming weeks. But it's worthwhile looking into a couple of videos, YouTube videos, that explain folder structures on PCs, and what does it mean, what does a command like cd or change directory mean, actually. Yeah. So I'm aware of that, but it's not part of the course, so I'll sort of de-emphasize that. But I'm aware of the needs for amongst some of you, and I'm happy to help.
Okay, still some question from Berking. Following GitHub codes, I can run machine learning algorithms for text mining.
Yeah. So there's ML, machine learning languages or libraries for Python. And I think that is the strength of Python in particular. But I try, as I said, I tried a couple of these, skitlearn and TensorFlow, but the ease of learning it is so overwhelming. It's just very simple to learn. So I may spend some time at the end of the course doing that and explaining a bit of that. But it's just extremely funny and powerful and cool.
Okay, there's another question here. Is there any easy way to extract table content from a number of PDF files using Python?
Yeah, there's a couple of modules and libraries that do that. So I recently came across a couple of, one example, but I couldn't find it any longer, where it uses various AI techniques to extract tables from PDFs, even if it's messy PDFs or scanned in using a picture taker. So there's that, but there's other, and just Google it, like how can I import PDF into Python, and you will see that there's a couple of modules that do that. Yeah, so it can be done, but it's not always easy, and sometimes it can be messy nevertheless.
Okay, now we have a question from Song. How can I access the SEC data with Python programming?
Yeah, well, that is the Edgar data in particular can be approached using Python. I may, I think I had planned something like a session on getting that sort of data into into Python going forward, because it can be done. It is doable, and it's it's one of these things where Python has its strengths. Yes.
Now there's a question, very interesting question here for you, Martin. What is your opinion? Does the basic of programming could be incorporated in courses in econometrics or accounting programs, or should it be separate programming course to gain deeper knowledge for accounting and finance students?
Really mixed feelings about that, because courses may run at some point and may be relevant at some point in time, but the flavor of the month, with programming language, the flavor may change over time, or courses may not be updated. So my suggestion would be, like, follow a course like this at a time that you're ready for a Python course, and I and you may hope that we keep this course updated. But assume maybe a new language like Rust or Julia taking over in a couple of years, and then you have to learn that language instead. So separate courses can be stifling in that they focus on the past more than on the future. So my suggestion is do whatever you need to learn the language. Feel the need, once you feel the need, start working on it, and follow a course like this or other courses, or get your books sorted and start. Just begin, and translate your problems into Python, and then start working with it. That's the best approach. And relying on courses makes you too dependent, and forces you to wait until the course is offered. That is wasteful time. So it's better, waste a better and more efficient way of using your time to just start and begin with your projects.
There's a question here in the chat window. Does Python have some ready financial tools like MATLAB to use?
Pretty much, I think. There's a lot of Pandas in particular is very apt for financial data. So not on the top of my head, because I hardly use these calculations, but you should be able to use NPV calculation or NPV functions in Python if they're not already provided. The best thing is, if you Python is such that if you don't find a financial function of your liking, you might as well program it yourself. Black-Scholes can be quickly written into Python, and so yeah, well, if it's not there, best thing is do it yourself. But there's a lot of stuff already available.
Okay, Martin, we have I think a final question here. Does the software applicable for analysis of statistical data in marketing field?
I would not know why not. I think it would be available for marketing as well. It's just whenever there's numbers and structured data, then Python would work with it. And even if it's not structured, you can use Python to structure it. So there's no reason to believe that in marketing research is so different from accounting research that it cannot be done. In particular, forecasting demand can be done easily using Python based on, say, consumer purchases at supermarkets or store data. It can be done. So that's
okay. We are coming to the. Go ahead. Sorry.
There was one question I used from I use R to textual analysis, but it tested a number of R packages yesterday, and unfortunately, SEC has now stopped access. All right, yeah, okay. That's a bit of a pity if the SEC starts blocking users. All right, yeah, that's a problem that I run into with the Reserve Bank. Our Reserve Bank doesn't allow you to remotely download data in Python. So you have to go to the website, download it first on your drive, and then analyze it, which is inefficient, but nevertheless, and maybe the SEC is doing the same thing to prevent the excessive use of bandwidth. Fair enough. I'm sure that on Stack Overflow there are workarounds for that. I have a website that downloads stuff from various sources, and it may be sometimes it's blocked, and then my script puts it into a waiting for a couple of seconds and then tries again until it gets the information that it needs. So there's ways around of that sort of stuff. Number of requests, yeah, limited. So yeah, there are workarounds for that to make sure that it 10 requests per second. So then it's you can sort of have a wait function that slows down the requests, to exactly 10 per second, which is not bad.
Okay, Martin. So now we come to the end of the session. I just want to know that everybody knows that this video will be available to the participants in the EAA website. We're going to provide the Martin email so you can contact him for additional questions. At this point, I would like to thank Martin for joining us today, showing the potential of Python to accounting research. I encourage everybody to register for the new live session starting on January 27th, where there will be 5 live sessions about Python. We are pleased to host you, Martin, and thank you everybody for joining us today. Thank you very much.
Thank you very much for hosting me, and thank you for showing up in such large number. It was a pleasure. And also happy holidays.